Hey, Hong, do you want to share that if you can share in your screen to just confirm?
Yeah. Okay.
Will you be able to do that, or you still have trouble?
I'm ready.
You can share. Try give a share to see if it works.
Okay.
Yeah, it works. Okay.
Okay.
Yeah, no problem. Okay. Let's wait for other folks. Yeah, let's wait for a couple more minutes. Yeah. Hey, Kentaro-san, I saw you here. Yeah.
Hi, good afternoon.
Yeah, I put one comment in last week's meeting minutes. I feel like since you have the service provider background, you may need to NPR's label info, right? Yeah, that probably will be more works.
Yeah, actually, we are not at this moment using that.
Okay.
But yes, as a comprehensive enhancement, I think that's a good point.
But today, have you guys tried to passing down the label information from the zebra all the way down? I remember someone mentioned to me that they have some private code to do that, but I don't remember anybody merge it to the upstreaming it.
I'm not sure. At least it's not our team, so maybe someone in other.
I think you need to talk to Carmine Scarpetto.
Okay.
I think he's the one who's doing it. He's been working on that. So he's got his own private stuff that he's been slowly upstreaming stuff with.
Because the last time when I have a chat with one guy from the China Telecom, they are doing something like then I ask them to say, how do you passing down the label info? And they say, hey, I have something private, but it never be upstreaming. Interesting.
So yeah, I not related to that, but for SRv6, I was curious if it's working on SONiC VS, for example, KVM.
KVM SONiC for the SRV itself, I think it does. I think,
Mhm.
yeah, but right now we are trying to merging the SRV6 VPN code.
Mhm, mhm. So SRv6 works with Linux kernel data plane.
For the basic SRV6, yes.
Okay.
But there are some limitations. I don't remember because since we have the Verve cases, then it's not there anyway.
I see. I see.
Yeah. Okay, so I think that's a good part of the forums. So today, I think today we want to continue from the last week, which Kantara gave the talk about, like say, we NetHub groups. So there are two topics for today's one. We want to continue from there. One is like I want Hongyu to describe what his pro-buff approach, because that's something which I was thinking that Kantara can help see that if you can leverage that, because currently, because you are limited by the NetHub basic netlink message format, so we don't have the NetHub groups. So that's probably like say you can consider about it. The second one I want to like introduce this, let Gongjian to talk about, like say and the recursive NetHub use cases and the problem we are facing. So ideally, I would prefer, like I say, can we do the like I say recursive, proper recursive support instead of that zebra clapping it? That's something actually I want to discuss also. So that's for today's two topics. So before we start, any comments before we really started? Yeah. Okay, so Hongyu, you want to go first? Let's talk about like your like say pro-buff approach. Yes.
Okay. Hello everyone. This is Hongyu from Alibaba. Today I'm going to introduce my project about adding a new data plan using protobuf. The current data communication methods are supported by FRR are shown in the figure. The methods we are currently using are marked in yellow. Now we have the problem that we need data in other formats to communicate with the FPM syncd. And now in the community, people are more likely to use FPM NL data plan instead of FPM module to transmit data. But FPM NL only supports netlink data. And considering the above, we decided to add FPM PB module, which is able to pass messages in protobuf format. The advantage is that the module can be controlled by the start option and doesn't affect other modules. In the short term, FPM PB and FPM NL exist at the same time, and in the long term, we hope FPM PB module to deliver all the messages.
So what's your backwards compatibility plan?
Sorry, pardon?
So what's your backwards compatibility plan? Not everyone's going to move to using protobuf for FPM, for their FPM module.
So we will probably start with like I said, the new stuff. So say for example, SRv6, we're targeting for the policy and the MySID, those like say special one. Then for the netlink part, I was thinking that if we want to like moving, say for example, like Kantara's part for the NetHub group. So if the moment we started, we probably need to say, hey, moving those things to those NetHub groups. But then for the creating the message, then since right now we have like the FPM, NL, and FPM.
I don't think you quite understood what I was asking. So I'm going to interrupt, sorry. Not everyone who's using the data plane module is going to switch over to FPMPB.
Yes.
So, and when the statement, the solution statement says, in the long term, FPM will deliver all messages, thus implying that the FPM netlink is going away.
And yeah.
The point I'm trying to make is
Okay.
that not everyone's going to switch over and be a solution that completely turns off FPM netlink or doesn't provide the ability for people besides SONiC to use FPM netlink or whatever they want to use is going to be a problem.
I see your point. So I probably we should rephrase it like in the long term for the SONiC, we probably just avoiding these dual link models. So then for people who want to stick with FPM, probably netlink, they will still stick there, right? So in the sense that, like I say, this will be controlled by the compiler. You can do the compiler flag controlling on that. So, but this is more from the SONiC point of view. In the short term, we have a dual pace, but it doesn't mean that we are removing the code for the FPM NL, right? But just say like for compile point of view, if we were, or like not for compile point, more for the enable point of view, like I say, if your FPM PB will be enabled in the long term, SONiC stuff will move into the protobuf.
Okay.
Yeah, we are rephrasing it. Yeah.
Next, I will introduce my main work. I register a new data plan provider IPM-PB to communicate with IPM-SYNCD. Like IPM-NL, it uses the same code infrastructure to get it and communicate. IPM-PB will encapsulate received data with protobuf 3. Then it will send it to the specified port by socket. For testing purpose, I sent encoded data through IPM-PB and created the IPM-SYNCD simulator. About IPM-SYNCD simulator, it's a socket program that listens on port 2620, and it can parse the received data into the specified format with the same profile. For example, IPM-PB in Zebra transmits message in protobuf format to simulator, and the simulator will pass received data and store it in the log file, so we can look at it. That's my introduction. Thanks all.
So what he currently doing is basically set up the one communication channels. So then he's reusing he's reusing the existing protobuf, the definitions. It's in the current FRR. So Donald, would that be that code is still live, right? Or you want to like create a new protobuf files? Sorry, you are on mute.
I wisely muted myself so no one could hear me typing. I'm not sure I have a preference one way or the other at this moment in time. From my perspective, modularity is important. I haven't dug deep into the protobuf code at any point, so I don't really have a ready answer for you without pulling that code up and spending some time in it. So I don't have, it's a non-answer, but it's what I got.
What's the history about like currently the protobuf code in the FR? It's like say the initial pilot code, or
yeah, I think Renato wrote it probably 4 or 5 years back. And I think he was doing a prototype for Juniper. Something they were doing. I don't know that it's widely used, in all honesty. It's just there.
Okay.
Like I said, someone wrote it because there was a project that used it. And like I said, Juniper one time wanted to prove that that you could drop any route and stack on their system and have it work. And so he communicated to the Juniper data plane via protobuf.
Oh,
So
I see.
let me see if I can find that. Give me a second here. Let me pull it up and see if I can find the.
Because right now we are leveraging the existing infrastructure, then it'll be easier. But so that's why we didn't. We just piggyback the new format to the existing ones. Okay. Yeah.
Yeah, I'm not seeing a quick link to it anymore.
That's fine. Yeah.
It's been long enough that it's probably lost to time. But yeah, no, I don't think anyone's really using it. But you
Okay.
know.
So which means that we could take over that, refurbish that one.
Yeah, refurbishment is fine. So from my perspective, if we don't have a TOPA test that enforces some level of functionality, how do we know that we don't break anyone? We don't have a way of knowing. So
that's why we introducing another like simulator.
Yep.
Then we need that one for testing.
Yeah, and that's the thing we've and prior to at one point in time we accepted most code without really Blinken and Newton have a requirement that there was any type of testing or any testing infrastructure. And this was in that time when we got this code. So is anyone using it? Don't know. I haven't, I usually gauge how people are using it if we see any patches. I bet you there isn't any real recent activity in any of those files. And you could probably figure out who the author was by going and looking at the original and going and talking to them. They're probably still around.
Okay, that's good. Yeah, I think our public strategy will be first move in our the simulation code, which we can using for testing purpose. Then we will move in these pieces, which more like I say the first guide to using this for other testing. So then we can basically have a testing to secure this channel. Yeah, so then we probably later on can discuss this one in the following meeting to see how we move in those code. Yeah, so the main purpose for this one is more like I say, give the Kantaro something. Hey, we are seriously to introducing this one. The main reason is we are introducing this for the SRv6. Yeah. Okay. Good. So that Kantaro, you'll be okay with this one?
I have a question. So what is the issue if we have both FPM Netlink and FPM PB? Because I think even just for SONiC, if we are kind of moving to PB only, that means we are kind of recoding the feature we already have, right?
My objection was mainly from a standpoint of if there was a bit of code submitted to FRR where the Netlink ability to send Netlink messages through the FPM was completely turned off, that'd be a no-go from my perspective. They must be able to coexist at the same time. And the end operator must have the ability to choose which one they would like to use. That's what I was objecting to, or ensuring that that was understood, I guess is what I should say.
The reason we pick a separate module is because like I say, we don't want to like breaking the existing like a Netlink part. That's one part. And also like a Netlink part for the initially we are thinking hey, Netlink part is mainly for the routes. Then we will put the other pieces in there. But Kentaro, actually, you bring out a very interesting point, is because the moment you start with the NetHop group, you pretty much like we cannot coexist. So we need to moving them together to be one from SONiC, at least from SONiC point of view. So then the question is like how much effort we want to put to moving them, and when we moving them. So because, if, for example, the next
I would actually argue that that statement is not true. I could send a netlink message that encodes a next-hop group like you're proposing, and it would be a legal netlink message. But if I were to hand it to the kernel will be like, what the hell is this? But I could write a netlink message with using embedded next-hop groups that would allow it to work.
But then then if that's the case, then we need to combine them to be a single socket, not a two socket. Because
I don't believe that statement either.
Why?
I'm just saying that the statement that you can't send next-hop groups with different levels like you're proposing with netlink is not true. What is true is if I were to send that data to the netlink message with multiple levels like you're suggesting to the Linux kernel, it would go, I don't understand this message. But you can embed that data inside the netlink message. It's just a netlink message. There's nothing inherent in the way you can build the next-hop group message via netlink that says I can't do that.
So let's think about say if a Kentaro making this next-hop group, but this next-hop group information will not go into the kernel. So which means the netlink message between the FPM and the kernel will be different. Right, so which means the FPM NL will creating this netlink message with the netlink group type, but then but if we will have two channels, then my argument will be like, say, what we meet will have some timing issues there. Say, for example, like NetHop.
No, but that's a different argument. That's a different argument, and I like I said, I'm objecting to the statement that you can't do that with next-hop. You can.
You could.
This doesn't make any sense from the Linux kernel perspective. And you're right that it would make the sending the data down to FPM would not look the same that when it sends down to netlink. Who cares? But let's not make our decisions based upon spurious logic, I guess. Okay. If we decide that we want to go this way, perfectly valid, and I'm not objecting to that. I'm just objecting to that you saying you can't do that. We can. We can make it work. And the question then becomes, do you want to make it work? And I think the real point is that there is the SR, the real kicker for me, from my perspective, is the fact that the SR, there is no, for some of the SR message types or the types of SR routes you want to install, there is no Linux kernel equivalent at this moment in time.
Yes.
But having said that, there is nothing right now, but that doesn't mean it's not going to happen in the future.
Agree. Yeah.
But since there is no netlink message, you have a choice for that. You can define a netlink message that allows you to send that data down, and you could then write like headers that abstract that a little bit and submit it to the Linux kernel and go, I don't have the full underlying implementation, but I think the netlink message would look like this. And that would be fine. And then you go, oh, okay, sure, we'll take that. Maybe, maybe not. I don't know. They probably would. That would be a decent argument from my perspective. Because then you can go, when it's finally time for someone to implement it, they can just use this message type. But I don't know that that's worth your time or effort to do. So what you're doing is fine. Okay.
Good. So your suggestion is, like I say, may not worse. we could add in the protobuf, but not worth to converting that link to the protobuf. Is that what you're suggesting?
I'm saying that I'm not sure that it is worth it or not. I do agree that having two different channels to send data down, and some data goes down A and some goes down B, that is a recipe for a lot of not fun.
Yeah.
So there is validity, but like I said, there is there's nothing to preclude the Linux kernel accepting next hop groups like we're talking about in the future. And there's nothing to preclude the Linux kernel from doing SRv6.
That's true. Mm-hmm.
And I don't want FRR
Mm-hmm.
to be put, I don't want FRR to be put in a place where all of a sudden the reverse is true as well. Most things work in protobuf, and all of a sudden the netlink comes along and someone wants the netlink. So people need to be able to pick and choose and be able to understand what's implemented there and what's not implemented where.
Mm-hmm.
And since SONiC isn't working on the Linux kernel, there is no equivalent, well then okay. But someone will eventually write that code for the Linux kernel, and we need to make sure we think about that. We can't just that we should be able to make sure that when the Linux kernel comes up, someone can write a little tiny bit of code and it will just work for Linux kernel too. And I don't want anything done that doesn't allow that inside of Zebra. That's all. That's my point.
Okay, gotcha. So okay. So then, in the other hand, in the sense, like I say, should we combine instead of two socket, combine to be one socket? Let this protobuf as a supplement. Say, for example, if in the future, it basically is just a green layer, right? Today we have the message type. Right now we define the protobuf, but nobody really using the protobuf. Only the netlink message in the FPM will be used. So do we, like say, instead of create a separate channel, the other way we can do is basically let the message type to determine it. Then which means that if you have a message type, then we can basically say, if later on, say for example, like say, if some feature full will have the.
Nah, it's a runtime decision. That's another recipe. Like, what happens if you have a message that's protobuf only, and for whatever reason until you've run for 2 hours, that you don't want to switch back and forth.
That's true.
It should be a runtime. It should be a compile time decision, or a specific module chosen, or a CLI command that says use this type when I communicate. Something very early in the start of Zebra should make that decision, because I'm not going to want to switch back and forth on it. Like if I'm running SONiC, I'm just going to choose one and go with it. I don't want to switch back and forth. That makes no sense.
That's what I agree. My question is, like I say, because the moment we add in two socket, then it will be looks ugly, right? Because we won't.
Yeah, you just set it. We should be able to set it so that when it starts, it goes, oh, I've been told to use the proto socket, so I will use the proto socket and not try to communicate via the netlink.
But only for certain messages, right?
No, for all messages. You should do one way or the other.
No, but then that's what I'm a little bit hesitant. Like if we go in all messages, the effort will be upfront is very huge. That's why I kind of
well, that's kind of that's the problem with this kind of world, right? You can't have your cake and eat it too in this case, I think. So like having two channels is a horrible recipe for disaster, because if one side gets backed up, or I need the setup for the SRv6 needs to go through the netlink first, but the SRv6 goes to the FPM, but I happen to read the FPM command first.
Yeah.
I'm sorry, the protobuf command first, and then the setup doesn't work. Yeah, like I fixed too many bugs, like where the two different, you know, it's like the threading issue where two different threads are trying to communicate, and the order that you do stuff doesn't work very
great.
well.
Yeah. Mhm.
So you need to pick one and provide the ability to do it all, in my opinion. I mean, or live with the fact that there could be bugs like what I just described, right? Where the ordering matters. And if you have ordering matters, maybe you need to send sequence numbers down and make sure that you do things in the right order.
That's true. Because previously, like if we just deal with the SRv6, it's better, it's easier. So I'm pretty much like separated. But at the moment we want to do the NetHop group, then we pretty much need to merge with the netlink. That's why I was thinking that should we like say using compile time to decide, hey, I have like say enable this probuf as supplement, then combine them to be one like a socket instead of the two socket. This way, then I could like say much cleaner to doing this work. So because today we already have the message, that's why I would say like if I using that message to determine how I decoding it, then I will select the proper encoding decoding to handle it. So then this will be basically based on the runtime instead of doing the completely plugin. So that's why I want.
One fundamental question. So Zebra is capable of having two FPM NL and FPM PB, and based on the information type, decide which channel to use.
Yes.
So we already have that infrastructure.
No, in the sense that today I try to avoiding just like so here's one. We pick the two channel is more for the for like a separate, easy to separate out, because the SRv6 is kind of like standalone at this moment. But then my concern, a little bit concern, is like say the moment we want to use that usually also using the NetHop group, then we have, if we have two channels, then we always have timing issues or potential timing issues. Say which one you FPM pick first, right? So then using the message type and combine to be one socket probably will be more reasonable. That's my thought process. Right, because then we can using like a message type to determine, hey, this is unless that part get corrupted. Otherwise, we can use that one to determine, hey, I will using the netlink to decoding, because today we have the switch statement anyway. Based on that, we go jump into the netlink format to decoding. Then we can using another one to jump into the probuf to decoding. So that's why I want to seek you guys' opinion to see that would that be more reasonable compared to currently like a two channels approach. So what are you guys thinking on that?
If I'm thinking out loud, but if we are using single channel, then I maybe just sticking to netlink with original data structure might be easier.
But your netlink currently don't have NetHop group, right?
Yes, but if we are defining some protobuf stuff, then I think we could also define netlink message, which kernel would not understand, and only SONiC FPM syncd would understand. But even if we use protobuf, I think the situation is same, but just that we have two channels.
That's true, but then the question for the protobuf, my fear is like say the effort to using the protobuf is easier because you just the FR side. The moment you want to netlink, then you need to go to the kernel to commit these netlink messages. then you need to wait for like a patching to the kernel to be updated. Then you can start using it. So there'll be a long cycle to getting there.
I'm not sure if that. I don't have enough understanding about FPM module that if that is true.
No, but no, what I mean is like say, because the moment you commit to the kernel, you need to then we need to update the kernel to get this header files, right? Unless we cherry picking it.
Right. If you want
that's not true.
Mm-hmm.
So the point of the header file, like I was saying, was to reserve the functionality for all new kernels.
Mm-hmm.
And you can then, like, one of the things we commonly do is if you go look in the include Linux directory, we have the header files that we depend on. And the reason why we have that, because I could possibly compile in FR on a 3.16 kernel that doesn't have the next hot groups at all.
Mm-hmm.
So we need to be able to provide those kernels so we can compile, just compile, even if we can't use it, we'll be able to compile against it. So you can take that header file, plop it into the FR directory. This is a common problem that happens in open source when you have to work against many different kernels. And the solution that we have is to take the include, and if you go to pop the header files as necessary into the include directory of your own project.
No, but then from the releasing point of view, you mean like say, do I commit those header files into the FR? I won't, right?
Oh yeah. Oh yeah.
Oh, you okay.
Go look at like I said, I have to be able to compile, you know, like let's take next hops, just the bog standard next hop groups from a Linux kernel perspective. When it was introduced in, I want to say 5.18, right? But I need to be able to, someone's going to take, so the FR has to be able to compile as if next hop groups to be able, I have to be able to compile FR as if I have to, like I can build a netlink message, because the only way that FR can tell if the kernel has next hop groups is to send a query to the kernel saying, dump me all your next hop groups. And the only way you can have that is if you've taken the header and compiled against that header. So at runtime, very early in the runtime, one of the first things that FR does, it sends a query to the kernel and goes, dump me all your next hop groups. And if the kernel returns us a, what the hell are you talking about? We go, oh, this is not a kernel that supports next hop groups. Turn that off so that when we encode the netlink messages to the kernel, we don't encode it as next hop groups. We encode it as the RTM new route with all the different next hops embedded in it. But that is a early runtime decision, and we must be able to support that for any Linux kernel netlink message that we may depend on. We have to be able to sanely build and also sanely talk to the kernel. And so the solution is that we take the kernel header files, drop them into the FR include Linux directory. If you go look in there, there's artnet, or the netlink.h, there's bridge.h, there's ifadder, there's a whole bunch in there of the Linux kernel. And we actually also have FreeBSD examples of the same problem, and NetBSD and OpenBSD, like they all have different versions and all different functionality, and they have different headers, and we have to be able to support them. So like I said, the solution is to drop them in there and move on. You don't have to wait if you got a header file that's been accepted upstream at some point in time, and you just want to be able to use that to be able to build whatever, you can just drop it in place and move on.
Okay, so you are saying like if I define, say for example, like some net hop group or netlink message, you allow us to commit into the FR.
What I said was that if you define the embedded next hop groups and define that ability, what I would do is I would go up to the Linux kernel and go, I want to be able to do this because I'm going to send this type of message, and you can't do this yet. But here's how I would do and here's the problem I'm trying to solve. And maybe someone will go solve it, but here's how I'm going to send the netlink message, because sending a netlink message that it can do it or not is different than actually handling the netlink message. One of the things Linux kernel does is that it states is that if it receives a netlink message that doesn't know how to decode, it just fails it goes, I don't know what to do with this, and fails the netlink direction. Like, so if I do an RTM new something that it doesn't understand, it'll just go, I don't know what this is, and drop it on the floor and complain to you. So it's safe from that perspective. The netlink messages have to be forward and backwards compatible. So if you are able to come up with a next-hop group way to write next-hop groups with netlink that are embedded and allow you to do a little bit more sophisticated stuff, then you can probably convince the kernel community to take it. Now, having said that, from a next-hop group perspective, I was kind of thinking about that a little bit this week. And part of, and maybe I need to see an actual setup of your 256 next hops, but I bet you some of those next hops are redundant with each other. Is that
it is redundant? In the sense, maybe like we can jump into the next talk. Well,
so like one of the things that FR does not attempt to do right now, which what we've known about is, and maybe will solve the generic problem that you're kind of seeing, is that if I have next hop A that recurses to next hop B and C, and I have next hop D that recurses to B and C again, you get this B and C, then B and C, and then you get these duplicates.
Yes.
We don't make any effort to go through and dedupe and minimize. And I think that some work could be done there that might make things just work so much better for you guys.
Actually,
and maybe that solves maybe that solves the next hop group of next hop groups problem you're running into as well. I don't know.
Yeah, I'll probably let Gongjian to start that to describe our use case. Then we probably continue to discuss this topic. Yeah. Gongjian, you want to start?
Okay. Could you see my screen?
Yeah.
Hello, this is Gongjian from Alibaba. I will introduce the recursive next hop use case in Ali and the issues we encountered in this use case. Here is the use case picture. We have three types of switches in this use case. First is ENBER. It has 32 uplinks connected to RSWs. And there are total 32 connected eBGP neighbors between RSW and the ENBER. And then a group of 16 DSWs. This switch is multi-hops away from RSW and ENBER, and it will have multi-hop eBGP neighbors with ENBER using the loopback IP address. So let's focus on ENBER. It will have 32 directly connected eBGP neighbors and 16 multi-hop eBGP neighbors. And then when we check the root table on ENBER, we will find 16 DSW loopback IP address, and it will each will have 32 next hops that connect to RSW. And once we announce the route from DSW to ENBER, then this route will just like this. It will have 16 next hops. That's a recursive next hop, and each recursive next hop will be resolved to this 32 RSW next hops. This is a total picture of this use case, and I will show example of showing IPBGP summary on EMBER. We could see that there are 32 direct connected eBGP neighbors with RSW, and 16 multi-hop eBGP neighbors with DSW. When DSW is announcing, we can check that the root 100.0.0.1, it has 32 next hops pointing to this RSW IP address. And once the root is announced from the DSW, we could see that it will show like this. It has 16 recursive next hop, and each will resolve to the same 32 RSW next hop. So here's the first issue in this use case. In reboot process update function, it will use the next hop group active next hop num, this function, to calculate the active next hop numbers of this root. And in this use case, it will calculate 16 times 33 equals to 528 active next hops. And once there is including the recursive next hop and including many duplicated next hops, and once there is a link flap, is the next hop active number will turn to 512 next hops. This is a magic number, since in the next hop group active next hop num, it's using an unsigned int type to return the next hop value. When we have 512 next hops, it will turn to 0. So that's the first issue we encountered, that once the link is flapping, the total prefix is withdrawn from kernel and FMCD. And I have proposed a PR about this issue. We just modify this return value from unsigned 8 to unsigned 32. That's the first issue. And another issue is about the FPM message length. So we know that there is a FR building parameter, enable multipass 1256, which means Zebra will sending a route matched to 1256 next hops to FMCD. However, in this scenario, it will send 556 next hops, include 1224 duplicated next hops. And this kind of route, it has a very large FPM message length. The length of this type is 4148, and however, in FMCD, which it will check the message length, and it can only handle the largest message that can be handled is 4096. So that's the second issue we encountered. When we in this use case, the FMCD just cannot handle this kind of message. Yes, that's all about this slide.
Can you go back to the previous the usage slide, the first slide? Yeah, thanks. So Donna, this is basically the usage case. So this is what Gongjian gave it's basically 16/32 ECMP case.
Yes. Yeah. So we have a lot of repeats.
Yes. So that's why I feel. Yeah, go ahead.
So I don't know that we can't, we do have some duplicate detection, but I don't think that's actually been extended enough. because I don't think we've actually, you're the first, Alibaba is the first group that I've actually seen where they're actually someone's actually trying to implement this at a scale that's large enough to cause a problem. So like I said, I haven't really thought this through fully yet, but it sure seems to me that we can have, we try to resolve each individual next hop to what it is, but we don't actually try to spend a lot of time deduplicating. And maybe that's what we really need to do is deduplicate all of that.
Actually, I would have had other thought, like say, instead of deduplicated, can we keep as a 2 level of the next hop group? Basically, we have the BGP level next hop group, then over the IGP level next hop group. So then the benefit for that is, for example, if I have a one link flapping in the 32, the bottom 32 links, I don't need to impact the prefix on top. So then convergence will be better. That's why I was thinking that once Kantara give the Netscape group concept into the net Zebra, this kind of problem probably we can rethinking it. Should we clapping that to be 1 level, or should we keeping them at 2 levels? Because in this particular case, if we keep in 2 levels, then its convergence could be solved in much better time. So that's why I was thinking that once Kantara introducing Netscape group, this is a good opportunity to enhance this kind of use cases.
Yeah, I just don't know, I haven't spent enough time thinking about it to really give you a good answer here.
Because this is basically it's on the global table. So this is the kind of very typical, like say, global BGP over the global IGP kind of use case. Then last time when Shansha gave the SRv6 talk, we also have the similar one is on the VRF table. Then IGP convergence today will be re-downloading a whole BGP convergence. So that's something that's where we have a discussion saying we should tracking the prefix with Netscape groups discussion. Yeah. So that's why I would feel like say if we taking if this time we're introducing Netscape group concept into the Zebra, then we probably can revisit all these use cases to see that what we want to do the BGP Netscape group versus the IGP Netscape group. So let them recursive. Then this one will basically say if Linux kernel cannot do the recursive, then we need to clapping there, but instead of the clapping into the Zebra, and so somehow Zebra just tracking the dependencies. So that's just I thought about say if that's possible to, that probably will be helping our convergence story will be much cleaner.
I don't know. I think it just it's one of those changes that would touch everything in Zebra.
That's true. That's true. Yes.
And I'm just hesitant to. I haven't spent enough time thinking about it. That's one of the. It's so big, and I'd like to spend a few minutes talking with some other people in the FRR community with them. I can't do it now, obviously. I think I understand the problem better. I actually do have a couple suggestions. So about the first pull request. See if we want to go to that slide real quick.
Yeah, you want to.
And this pull request is stalled because I think there's the problem was, and I didn't know how to really talk about this without so just changing the next hop uint 8T to uint 32T is like putting a band-aid on a like a gushing wound, right? I think the problem is there's two different problems that we were trying to solve, that we cheated and solved with one with the one UN8T, and I think the roosters have come home to roost here. But the first problem was we were trying, well, I mean, I shouldn't say the first problem, there's a bunch of problems. The first problem is that we were trying to limit or know how much data we needed to send between Zebra and upper level protocols for when we send a Zappy message for the next hop. And the easy solution was to max the limit to what we've compiled FRR to. And the second thing that went on is that we just counted the number of next hops to know that were active, to know whether or not any of the next hops were good. And we didn't consider this use case here. And so I actually think we have, I think just changing a UN8T to a UN32, it doesn't really solve the problem. We have two different problems, and we conflated them to one problem and just made it work, right? So when we're counting the number of next hops, what we really are doing, we were counting the number of next hops and going, can we handle this in array to pass up back and forth? But that's one problem. And the second problem is we were using the count to know if anything was active. And we need to separate the two problems away from each other. And that's why I haven't just pressed the button on merge in this PR, because I don't think it goes far enough. And I didn't know how to tell your developer that they should go do that, because I felt that was a little unfair. But we need to go ahead. Go ahead.
I see that one comment is like changing this going to be the Boolean, right? So it's because
yeah, but you need changing it to a Boolean, but you need to go find out places we use it and decide whether we actually need a Boolean there or not, and we need to separate out the two different problems. Because we're using both the next hop count as both can we pass this via Zappy, as well as have we hit some fundamental, are we trying to handle too many next hops, or is this next hop group active or usable? And so we need to separate the two items. So bool isn't enough, because the place that we do the count in, we need to find all the places that we call that function and make sure we're doing the right thing for the part of code we're in.
So Gongjian, correct me if I'm saying wrong. I think that the last time we checked, this one mostly to decide if there's active members. So we pretty much using this as a Boolean, basically using 0 versus non-zero.
Right. It's used more. It's not just a Boolean, like I said. Like, let's say someone outside of FRR creates a route with 300 next hops, perfectly legal to Linux kernel. But now also suppose someone's compiled FRR with max number of next hops is 128. So when we start up, FRR queries the kernel, give me your routes, and the kernel hands a route with 300 next hops, and FRR goes, oh boy, we got a problem. I can't pass this data up to my upper level protocols because I've specifically limited the number of next hops.
I think,
and that decision was how do I make Zappy easier? And maybe we need to revisit that too, right?
That one, I think today the behavior is we just pick what's a max cap will be.
Yeah. So let's say what we do currently is if you pass in a next hop group a route with 300 next hops and we've limited to 128, we take the first 128 and throw the other 170, 162 away, right? 172.
That's
Throw them
basically
away.
the moment we claim, say, the maximum is 128 or 256, that means that this is a more like, say, the maximum from the hardware perspective, that's maximum I can take, right? Then if you theoretically, if you have that more than that, then we pretty much
Yeah, don't think about it. Don't think, let's not talk about this from a hardware perspective. This is a complete control plane problem.
No, but this is more like, say, you sending this message to someone who claim to say, hey, I can only take up to 256 or up to 128, right? Then you say, hey, I'm learning the BGP for whatever the reason, I get 300. Then from that angle, then give the first 128, may not be that bad. That's my point. Right, because you cannot really control to say BGP can only do up to 128 because they're resolving it. It's more like, say, the application tell you to say I only take the 128. Right, so then I think BGP does the correct job because he will handling all the passes he could, because he eventually he don't want dropping it because eventually someone losing some pass he can recalculate it. But this is up to the application, right? He said, like, although you calculate the 300 pass, I can only take up to 128. Then I think that's okay. That's from my opinion.
Yeah, I think we're in violent agreement, just coming from a different perspective. The like I said, things need to be separated. I just didn't. It just needs to be. We have two different. We're solving two different problems, and we cheat it with one solution when we should have had two different solutions, and that's where we are. And so even if we just made it a UINT 32T, we're not really solving the problem. And the second thing, you know, that you might want to think about for the issue 2 that you have, there's a flag that we put on each next hop called next hop flag duplicate.
Yeah.
Look for that flag and don't send, if it has a next hop flag duplicate, don't skip that next hop and don't send it down via the FBM.
Yeah,
yes,
that's all your problem.
Go ahead. You give the comments.
Yes, that's just what we have done in our side. We just check the next hop flags and bypass the duplicated next hop.
Okay.
We could upstream in that part, right?
Yeah, that would be that one. If you upstreamed it, I would probably take that pretty quickly, because we do that already with
You did that with the kernel, I think.
yeah, we did with the kernel already.
Yeah, so we do the same check for the FPM side.
Yeah.
Yeah, we can raise another PR2 for that. Yeah. So for this one, what do you how do we closing it? So if you say like should we like changing to the Boolean to closing the first one, for the second one is right?
Like I said, I think it needs to be pulled apart to solve the two different problems.
Yeah.
And I don't know how to describe that just over the words. It needs to, I need to sit down and find all the places, you need to sit down and find all the places that we use the count as both an act, whether or not it's active versus we're using the count to make sure that we don't try to send more data than the Zappy, and it causes ourselves a problem with Zappy. So there's two different things that need to be looked at.
Last time I thinking like we checked that the guy who calling that API is pretty much using as a Boolean purposes. I don't see anywhere we are using that for
it's definitely not being used as a Boolean. I remember a couple bugs that I have fixed.
Okay.
Where the number.
So someone already using that numbers.
Yeah, so like in the other thing that you can run into, people sometimes, you can compile with next hops of 256, but you can do a runtime of 128, or you decide whatever, like, or maybe the data plane, someone writes the data plane and you get a different number from the data plane. So we need to be able to handle that and pass it up, and it's just, we just need to be careful. And I'm just hesitant to say it's a one spot check. I think we need to check all the places that we send the Zappy, because it's a hard-coded array basically. And that's
Oh.
why it's this weird, you know, and that's why it was, it's if we want it to be more flexible and send more next hops than what we've configured, we need to think about that. Or just make sure we're doing the right thing. And I'm not sure we have those tests. Is all I'm saying.
But what's the concern you have, like say moving from A doing A to doing 32?
Like I said, we have two different problems. We're using it both as a Boolean and as a check to ensure. And B, or C, I guess, I don't want to make everyone pay the cost of making that value a 32-bit number for each next hop.
This is the transparent, like the transient, like a cost, right?
It's
are
not transient. It's you're changing lib. If you're changing that uint32, I thought it was a .h file we're changing, right? Go back to issue 1.
I thought this is the only, we changed the header file for the function, but we didn't change any storage, right?
Did we? I thought we did change storage.
I don't think we changed the storage. Can you open up your, like say, like the PR? I thought you didn't change the storage, right?
Let me pull it up.
A quick comment while you're looking for it. The changes to RIP with regards to recursion and direction are very invasive, and Don is completely right. It needs to be brought to wider FRR community to be discussed. So, as you know, probably a number of commercial stacks implement this functionality in kind of bottom part of RIP. And I think specifically to FRR community, we should definitely bring in AC Lindem. He did it before. I mean, we work for the same company, so let's discuss it in wider community. It's very invasive and potentially it's really a lot of work.
You mean? I didn't get, sorry, Jeff, I didn't get your comments. What do you?
The changes to, so you've complaining about kind of 2 levels of next hops and.
Oh, yeah, 2-level next hop. Yes, that's definitely, I need to, if I want to like get a consensus from our team here first to see if it's valuable. If it's valuable, I definitely need to bring this one to the FRR community.
Yeah, so again, there's a number of implementation commercial stacks. People did it before in RIP. It's a lot of work, very invasive work for the rest of the stack. So we need good discussion on the FRR part of, and we need to get people with experience of doing this before. And kind of my comment was, let's get AC involved and actually a few more people who worked before on commercial stacks doing exactly that.
Yeah, that's fine. Yeah, I can basically, so you want to like say, introducing this use case into the FRR weekly meeting, right? We can pick one, maybe the coming weekly meeting, we can discuss that.
It should be wider. It's very invasive. I mean,
sorry?
It should be discussed in FRR community, not just within kind of SONiC part of it.
No, I know. I always say like for the, say for example, next week, Tuesday's the FRR weekly meeting, should we discuss it there to at least bring that attention to see this is the use case? Should we have some, because this one will have a big change, definitely. So if we decided to say, hey, this is we have the value for that changing, then I would say like it could be the huge change there, right? So my question is like,
what's your view of how to properly organize the review of this?
No, I want to like say raising this as a discussion point to see if everything see the value to go in there, or we say, hey, there's no value. That's what we'll say. If you want to ever agree with that, we can come up with some HLD for that purpose.
So there's definitely value. I mean, again, it depends on underlying hardware, whether you need to flatten chain or some hardware can actually process all of it. My point, it's significant change and we need consensus of FRR community.
That's
to
definitely. Yeah. I just like I say, I want to first get some agreement with this team before I go to the FR community. That's the main reason. Yeah. If we thinking this is a good one, we don't. I think we can go to the next week or the following week. The one of the FR community, we can put this into the agenda. Yeah. I can reason this sending to the FR, like I said, discussion point to say this is something we feel like say, we can include this use case and also like SRV6 use case where we see the recursive. Because that one eventually will come up to see the how we handling the convergence, right? Yeah. Would that be sound okay for you, Jeff and Donna? If that's way, we can. I could probably raise the email thread and then booking one of the slot in the FR community. Let's discuss these use cases. Because we can pack this use case with the last time the Shangshai's the talk which described the convergence. We see the other use case basically IGB convergence which impact the whole redownloading. So that's the two issues I feel like they're related to this discussion. Do you want me to prepare some slide to discuss in the FR community?
I think it would be a good starting point.
Okay, that's good. Okay, let me start it, then I will let you know. Yeah. Good. We are almost 10 minutes over the time. So anything else?
Yeah, I actually have one quick thing.
Mm-hmm.
The FR community in the first week of September is going to have a meeting where people who are working on features like their company is working on, they're going to talk about it in the community openly. So I guess what I'm saying this poorly is we're setting up a meeting the first week of September. Like I'm going around asking all the people who are working on FR that I know of to come and spend 5 or 10 minutes saying, I'm working on these features. Here's what I'm kind of thinking about. Gotcha. And the goal from my perspective to get like, you know, there's been more than a few times where group A is working on a problem and group B is also working on it, but they're not talking to each other. And so it's just a chance for people to be able to talk together. That's good. So, you know, I would encourage people here to go to that meeting, and it's the first meeting of September. And if you're not sure how to get a hold of that meeting, poke at me and I'll get you the invite. Right.
I'll probably ping you offline on that to see that this is not the weekly meeting, that one, right?
Yeah, it's the weekly meeting. We're going to do it in the weekly meeting. So Tuesday, 11 a.m. Eastern.
Yes. I have that invitation. I just say right now I didn't participate because I don't have too much stuff to talk there. But as we conclude something here, I want to present the works which we did here or the issue we did here and discuss in the FR community. Yeah. Okay. Good. Okay, so let's stop here. Yeah. So
last question. Next week is ATF. Traditionally, we've been meeting with a couple of folks at ATF. Nothing is planned, right, for next week?
So you want to skip next week?
No, I'm asking about FRR folks meeting. We didn't schedule anything, right? This ATF, Donald?
So I know that we typically have a birds of the feather or whatever it's called now session that's over lunch at some point in time. There is during the hackathon, there's going to be several representatives from FRR to talk about to provide support for how to program in FRR. I don't think anything else in particular is planned.
Okay. Were you guys going to that IETF meeting?
I was
Yeah,
not
I
given
chair two
permission.
working groups and I have to be there for a variety of other reasons as well. So I'll be there full week. It's next week.
Yeah,
Until
yeah, yeah.
next
I got like say asked to go there also.
Yeah, it'd be nice to go, but not in the cards for me this time.
Okay.
Okay, thanks everyone.
Okay, thanks. Bye.
Bye.
Mhm.
Thank you.